So now our study of the imaginary number begins. Two pieces of information that you need to know about imaginary numbers. If you know these two pieces of information, then you can pretty much figure out any imaginary number problem. You first need to know the imaginary unit, I. And you have to make it a cursive I, or you have to hook it like I've done. Because if you don't, it'll look kind of weird like a 1 or an L sometimes. It gets in there and just looks crazy. Usually 1s are what we confuse it with. So try to hook your I or make it a cursive as you're writing these down so you don't get confused. I is equal to the square root of -1. Now, I'm not telling you that you can question this. When I say the sky is blue, the sky is blue. You just have to accept it, even if you look at it and you see purple. Well, this is what I is equal to, the square root of -1, and you can't question it, okay? It just is. That's what it is. It's its definition. I squared is equal to -1. That's because if you squared both sides of this first equation, wouldn't you get I squared equals -1? Okay? If you know these two pieces, you can do a whole lot. Okay? If you are taking the square root of a negative number, like -b, then what you will do is you will break it down into the square root of -1 times b. Then you use your multiplication property for radicals that says I can take the square root of this factor even if I can't take the square root of that factor. And I know that the square root of -1 is I, and b stays underneath the radical. Now that's an abstract application of it. We're going to move into some more concrete things now. Okay, that's just your general rule. So if I gave you the square root of -4, that means that's the square root of -1 times 4. What's the square root of -1? I. And what's the square root of 4? Can you do it? 2. So your answer is 2I. The square root of -9. I bet you can tell me the answer without showing the work this time. What is it, Antonia? I heard you say it. It's 3I, right? Okay. The square root of 9 is 3. The square root of the -1 is I. What if it's not a perfect square number? What if it's the square root of -12? Then we break it down. Always pull the negative off first. And you break 12 down just like you learned to a few sections ago. What's a perfect square factor of 12? 4. So -1 times 4 times 3. The square root of -1 is I. The square root of 4 is 2. Always put the coefficient in front of the I. And you're left with 3 underneath the radical. Any questions on that? Not too bad, I hope. Okay, let's move on. Let's do a problem in which we're multiplying two imaginary numbers. The square root of -16 times the square root of -4. Now, you may be tempted to use that multiplication property of radicals that we learned last week And you may want to say, oh, well, that's the square root of positive 64 because negative 16 times negative 4 is positive 64. Do not do that because this number is imaginary and this number is imaginary. And when you apply that property, you all of a sudden erase the fact that you were multiplying two imaginary numbers to begin with. Okay? So we handle the imaginary stuff first. The square root of negative 16 would be what? 4i. The square root of negative 4 would be 2i. We did it over here. Now we can multiply. 4 times 2 is 8, and I times I is I squared. Now remember, I told you if you knew what I squared was, your life would be a lot easier, right? What's I squared? Negative 1. So this is really 8 times negative 1. So your answer is negative 8. I enjoy working imaginary number problems. They're one of those things I think that a lot of math teachers like for some strange reason. Let's do one with a fraction. See if you can do that one by yourself. Remember to handle the imaginary part first and then worry about simplifying if you can. Okay, the square root of negative 121 is 11i. The square root of negative 81 is 9i. Now I have I over I divided by I. What happens? They cancel. And my final answer is 11 ninths. Now, if you are following along in your workbook and you will turn to page 423, you are going to see the first 16 powers of I. And I can remember being in school and trying to memorize those. Notice there are 4 things that they equal. They equal I, negative 1, negative I, or positive 1. And there's a pattern there, right? So it's not really something that you have to memorize. And I do not recommend you memorizing that, okay? You do not want to do that. It's going to, even though there's a pattern and it might be pretty easy, I think that it's just kind of a waste of brain power. If you know I is the square root of negative 1 and I squared is negative 1, then you can work I to any power, okay? You can work I to any power, and I'm going to show you that with some examples now. if I've got I to the 44th power, see, that wasn't on that list, was it? Was it? I to the 44th? I think that says I to the 14th. But it does look like a negative, but that's the dot on the I. It's hard to read that. But that actually only goes from I to the 1st to I to the 16th. Okay? So this is not on there. So you could sit there and try to count and figure out where you would end up in your pattern, and it would take you a lot of time. Or you can always break your problem down into I squared to some power, if it's even. And if it's odd, we'll tackle that in a minute. Okay? So I can write I to the 44th as I squared to the 22nd power, because 2 times 22 is 44, and we know power to a power we multiply. Okay? You know what I squared is. What is I squared? Negative 1. Negative 1 to the 22nd power. What's a negative raised to an even power going to be as far as the sign goes? Positive. And then 1 raised to any power is always what? 1. So the answer to this is positive 1. Now let me walk you back through it one more time. You've got a very large power of I. You do not have the list memorized. You know I is the square root of negative 1 and I squared is negative 1. So you see that 44 is evenly divisible by 2, 22 times. So you write it as I squared, because you know what I squared is, raised to the 22nd power. You replace I squared with negative 1 to the 22nd power, and then you do what you know to do as far as raising numbers to powers. A negative raised to an even is always a positive, and 1 raised to any power is always 1. You could also type this in your calculator. You just have to make sure that you put parentheses around the negative 1. Okay? Let's do another one. Let's do I to the 23rd power. That's not even, is it? But I know what I squared is, and so by George, I better make use of I squared, because that's the only one I know. So this could be written as I, first things first, to the 22 times I to the 1st. Is that correct? Now why would I do that? Because I know how to write 22 as a power of I squared. I squared raised to the 11th power makes I to the 22nd, doesn't it? And then I bring that times I over. What's I squared? Negative 1 to the 11th power times I. What's negative 1 to the 11th? Negative 1 times I is just negative I. Now, they have typed you a couple of little notes you could memorize there. I am not into memorizing stuff because it never stays. I figure things out, and I know that I can work every power of I by knowing I squared. I can do it. And I just showed you how you could do an even one and an odd one. Okay? So you will get either positive 1, negative 1, positive I, or negative I every time. That's what you're going to get. One of those 4 things. Now she's got two little tips in here for you. If the exponent is a multiple of 4, the result is 1. If the exponent is even but not a multiple of 4, the result is negative 1. If you are good at memorizing rules and you like that, memorize it and use it. Not me. I think it makes it harder, and I get confused. So, all right, any questions? Okay. The study of I, the imaginary number, moves us into the complex number system. You have a Venn diagram, a Venn diagram and a chart on page 424 in your book. And what it does is it shows you the way our number system is divided up. So you have the set of real numbers, and then you have the set of imaginary numbers. Within your real numbers, you have rational numbers and irrational numbers. And then rational numbers have subsets. Okay? Irrational numbers are any non-repeating, non-terminating decimals. So if you take the square root of a number that's not a perfect square, it's always irrational, always non-repeating, non-terminating. Rational numbers are divided into integers, whole numbers, and natural numbers. And you studied these. I would think in 098 you probably learned about your number system. Yay or nay? You did? Okay. Imaginary numbers are the subset that we've just put in there. The complex number system is all of our numbers, real and imaginary. Okay? A complex number can be written as A plus BI, where A is what is said to be the real part of the number, and BI is said to be the imaginary part of the number. You are probably wondering, how can something that's written as A plus BI be part of the complex number system, which contains rational numbers? If B equals 0, then look what happens. You're left with A plus 0 times I, which is just A plus 0, which is just A. A was what? Real, wasn't it? If A equals 0, then you're going to have an imaginary number, because you're going to have 0 plus BI, which is just going to be B times I. So this would be an imaginary number. You can have numbers that are that contain both parts. We could have 4 plus 3i. 4 would be our real part, 3i would be our imaginary part. Furthermore, as we learn about our complex number system, A plus BI and A minus BI are conjugates of each other. Just what we talked about Monday night. x plus 4 and x minus 4. The square root of x plus 4, the square root of x minus 4. We did that Monday night where we rationalized a denominator that had a radical in it. Okay, same concept. They're conjugates. And if you multiply conjugates, remember, when you multiply conjugates, you don't have to FOIL. Because the O and the I parts of FOIL cancel out. So you only have to what? Do the F and the L. Multiply the first times the first and the last times the last. Now I'm going to give you, are y'all finished with that? Anybody still need it? Okay. I'm going to give you a number, 5 plus 8i, and I just want us to discuss the parts of it. 5 is what part of this number? It's a complex number, so what's 5? Is it the real part or the imaginary part? That's the real part. 8i is the imaginary part. Is this a real number? Look over here. Is an imaginary number, see one of the lists, -3 plus 7i, is it a real number? If it has an I in it, it's over here. Is that part of the real number? No. Is it a complex number? Yes. Okay? But it is not a real number because it contains an imaginary part. Okay? It has a real part, but it is not a real number. Okay. Now, we add and subtract imaginary numbers. We'll use that one. Just like we do regular real numbers, any kind of algebraic expression. So I have here what looks like a binomial plus a binomial. Now I can't really call it a binomial. That's not legal because it's not a number. It's an imaginary number, but I'm going to call it a binomial because it has two parts to it, okay? Just to keep y'all in the same thought process. So we're going to add these two binomials together. 5 plus, we just add the parts that are alike, right? So 5 plus 4 is 9, and 8i plus -5i is 3i. If you have a subtraction sign between the two quantities, then you have to be careful. You just have to treat it like you've always treated subtraction signs. Usually we change them to plus, and then we just change the sign of everything that's behind it. going to add your like terms together, right? So 1.2 and negative 6.5 is negative 5.3. Y'all make sure I'm doing that right. And then positive 4.7i and positive 3.6i is plus 8.3i. Yes. And there's your answer. Just adding like terms. Always write your answers in A plus BI form. Now it can have a minus sign in there. It can be A minus BI or negative A, you know what I'm saying? But it always needs to be the real part and then the imaginary part. We multiply imaginary or complex numbers just like we multiply polynomials. So everything, the rules that we have are all the same, okay? So let's do a FOIL problem with that. 3 minus 8i times 5 plus 2i. You will have to do some simplification because you're going to get an I squared in a minute. So you're going to FOIL it. 3 times 5 is 15. 3 times 2i is 6i. Negative 8i times 5 is negative 40i. And negative 8i times positive 2i is negative 16i squared. So I'm going to add the two terms in the middle because they're both i's. Positive 6i and negative 40i makes negative 34i. And I squared is negative 1. So negative 16 times negative 1, or minus 16 times negative 1, however you want to say it. I'm going to show every little step. Negative 16 times negative 1 is positive 16. Then you're going to add these two numbers together that are like terms. So you're going to end up with 31 minus 34i. Any questions? Okay, let's multiply a set of conjugates. We talked about conjugates up here. If we FOILed the whole thing out, we would end up canceling the O and the I, right? The outer term and the inner term, or the outer product and the inner product. So we only have to do the first times the first and the last times the last. So 5 times 5 is 25, and then negative 2i times positive 2i is negative 4i squared. So that becomes 25, I'm showing every little step, minus 4 times negative 1, which is 25, plus 4, which is 29. Do you see a shortcut? Square the first term and plus the square of the last number? Did it end up being 25 plus 4? It will every time. So you can do a squared plus b squared. If this is a minus bi and a plus bi, your answer will always be a squared plus b squared. And you don't have to show any work, really. But that's just for those of you who are comfortable with that. Okay? Okay, we're going to divide complex numbers and then we'll be finished. So we've added them, subtracted them, multiplied them, and now it's time to divide them. I have 2 plus 4i divided by 3 minus 5i. Now what did we learn Monday night that could not be in our denominator? Or maybe the week before, I can't remember. What cannot be in your denominator? A radical, okay? We also learned way up here that I is really square root of negative 1. So I is a radical. Is that a proper summary? Okay. So that cannot be in my denominator, can it? So we need to take what we just learned about how conjugates multiply. Notice when you multiply conjugates, you always get a real number. And we need to use that to rationalize this denominator. So when we are rationalizing a denominator with a complex number in it, we are going to multiply by the conjugate of that denominator, top and bottom, which will be 3 plus 5i. Okay. In the denominator, you're multiplying conjugates. You can go through all of this again. You're going to get 9 minus 25i squared, correct? Which is going to be 9 minus 25 times negative 1. So if I show all the work, I'm going to get 9 minus 25i squared, which is 9 minus 25 times negative 1, which is 9 plus 25, which is 34. Again, I could have just said 3 times 3 plus 5 times 5, couldn't I? Every time. 9 plus 25, is that what I ended up with? How do I multiply this? Well, we just did it right here. What do you do with it? So binomial times binomial, FOIL, okay? So you're going to get 6 plus 10i plus 12i plus 20i squared. Here is 6 plus 22i. And then that's going to be minus 20, isn't it? Because it's 20 times negative 1. Add your like terms. Negative 14 plus 22i over 34. Now this is kind of where we ended the other night. These three outside numbers are all divisible by what? 2. So you got to reduce the fraction. Negative 7 plus 11i over 17. Now with complex numbers, when you're dividing complex numbers like we are right here, you have to write your answer in complex number form. Did you notice this was in complex number form, a plus bi? This was in complex number form, a plus bi. Wasn't plus, but I told you it could be minus. Okay, so we have to take this answer and we have to break it up into the real part plus or minus the imaginary part. You do that by taking that fraction over that fraction. Not over it, added to that fraction, excuse me. So it's negative 7 over 17 plus 11 over 17, and you just stick your I in the middle. Okay, I think we should do another one of those. I'd like for you to get started on it by yourself. Let's see what you can do with it. Okay. Okay, what are you going to multiply by? 10 minus I. What's the coefficient of I right here? 1. There's a 1 there, right? Okay. so keep that in mind. This will be 100 plus 1, is that right? So 10 times 10 plus 1 times 1, is that what it ends up being every time? Have I convinced you yet, or do I need to show you again? Let me show you again. This is what I think it's going to be. So if I multiply the first times the first and the last times the last, I'll end up with 100 minus negative 1, which is 100 plus 1. So it's always square the first plus the square of the coefficient of the last. So you're going to get 101. You're going to multiply the numerator out by the FOIL property. So I'm going to do some little shortcuts here, not show all the steps because you've already done some of it. You should have gotten 50, I'll show most of them though, minus 5i and minus 20i. Minus 25i in the middle, and then plus 2i squared. Is that wrong? Did I do something wrong? I might have. Y'all know. It gets late on me. We good? You think I'm good, Christopher? Okay. All right. 2 times I squared is 2 times negative 1, which is what? Thanks. So 50 minus 2 is 48, minus 25i over 101. I don't believe those share any common factors, so I will break it up, and then I can reduce one of the fractions, but not the other one. I can't reduce any of them, can I? That's why I wrote 100 there. So 101 minus 25 over 101. I keep writing 100. I say 101, but I write 100. 101i.
Would it be wrong if we left the I in the numerator?
It is a nitpicky thing that I think your computer program is going to expect you to put it out beside it, because they want to clearly see the A and the B. A plus B I. Okay? That's considered the form that you leave it in. Okay, one more problem and we're finished. And then if y'all need to stay, please stay, and I will help you with whatever you've got going on. Okay. This is just simplifying a radical expression that contains an imaginary number. So 15 plus the square root of negative 75 divided by 10. The first thing you're going to want to do is tackle this imaginary number. So 15, just rewrite it, plus the square root of negative 1 times, okay, what's a perfect square factor in 75? 25, that's right, times 3 over 10. Continue simplifying. 15 plus the square root of negative 1 is I, the square root of 25 is 5, and then you have the square root of 3 left inside, all over 10. Do the numerator and the denominator share a common factor? All of the outside parts are divisible by what? 5. So we're going to rewrite that. 5 goes into 15 3 times. 5 goes into 5i. I times leaves you with root 3. You never touch what's under the radical, over 10. Now, oh, I'm sorry. Yes, it will. Over 2. Yes. You can't miss class. I was getting distracted by the fact that they leave their answer like that in this book. But I don't think that it's proper to leave your answer that way. Consistently, they expect you to write your answer like this. So just be aware that you may have to write your answer like this. 3 over 2 plus root 3 over 2i. That's not how they left it in this workbook, so I don't know.